Assalamu alaikum dear students. Bismillahirrahmanirrahim. Welcome in lecture 16. In this lecture I am covering also a simply supported beam, but the beam is you can say the picture of the beam is a little bit different. Okay, so you see this beam. One thing I mention you students, that you must need to understand the supports, the structure which you have to model in your sap2000. Okay, so once you become the master of modeling the structure into the sap, then the analysis design is a simple procedure, that is not tricky, that is not complicated. The only hurdle for you people is the modeling of your structure into the sap, as well as on your ability that how much you understand your structure. Okay, so this is the structure at B and A. A is a smooth support, clear, and B is a pen support, or you can say hinge support. The question is selected from R.C. Hebler at addition this example. Okay, and in this example you can see point, or you can say support A is a smooth support. Smooth means it is a ruler support, and B is a pen support, and C is a hinge support. So how to model this beam? Let's see. We will do this example. Clear? So we will use grid spacing. Clear? Here you need to understand. Okay, you have x1 and x2. Okay, you have z1 and you have z2. So you have z1, z2, x1 and x2. Clear? Or you can say this is A and this is B. So your AB spacing is, this is simple span that is given as 10 feet, and you can say from A to C, that is the height, and that is given, that is 5 feet. Clear? So let's see and model it. This is in X direction you have 2 grids. In Y direction assume it is 1. We don't need this. In Z direction you have 2 spacing, 2 grid line. The distance between in XX grids, that is 10 feet. Clear? This is assumed, let's say it is 1. We don't need it. And the height, Z means height, that is 5 feet. Okay, so remove this one and make sure you will be in XY plane. So how to draw? Select this option, click here, then click here, and then click here. Okay, this is your beam structure. This is the origin point. This kernel point will be located from this origin. Its coordinates will be 10, 5, and you see there that is 10, 5, and this height should be equals to 5. So you can see here that is 5. So okay, you need to assign a hinge support there. Okay, that is joint, sign, restrain, hinge support. Okay, and there you need joint, restrain, and a ruler support. Okay, here we need to rotate this joint by an amount of 60 degree, but the direction should be negative because it is an anti-clockwise. Okay, select it, assign, join, local axis, and the rotation is about y-axis as usual, 60 degree with a negative sign. Okay, now assign the loading, frame loading, distributed loading. The magnitude of the loading is 150 pound. 150 pound. Make sure this is to 0. This is 0. Modify. Okay. And global force add to existing and okay. This is the load. Joints are assigned. Element is drawn. Loading is assigned. Now let's see. We will analyze the structure. Save the model, that is project number 16. Save, and let's see the reactions. So you can see this is 11196, this is 4098, and this is 9696, and I think the reactions are okay. This is 11196, 9696, 4098 pound. So this is the way that how we will analyze such complicated beams. If you are interested to draw the shear force and bending moment diagram, you can see the shear force and bending moment diagram, which will be like in this way. And if you are interested in bending moment diagram, so this will be the bending moment diagram. Okay. So this is the procedure for analyzing the different types of beams. Okay. At this example, I will stop analysis of determinate beams. After that, inshallah, I will start indeterminate beams. So indeterminate beams and determinate beams are simple. Indeterminate beams are a little bit complicated. But you must know the steps are same. We draw the model, assign the joints and loads, and then we analyze. Okay. But determinates structure or beams are those which can be analyzed by using the equations of equilibrium, and indeterminate structures are those which can't be analyzed by using of equations of equilibrium. So there are different methods for analyzing the indeterminate structures, like slope deflection method, moment distribution method, virtual work methods, and different strain energy methods are used to analyze such types of structures. So they are very complicated when we analyzing them manually. So sap2000 gave you a very easy approach. They did that analysis in a few seconds, which will take you can say hours of you students to solve them manually. Okay. So inshallah you will enjoy that session as well. Okay. After covering the indeterminate beams, I will cover frames, determinate frames as well as indeterminate frames, and then I will analyze some examples on trusses. Okay. So after that, inshallah, I will start the design of these beams, frames, okay, and trusses. So up to this lecture, if you have any questions, students, if you have any questions, any suggestions, you can share with me on my contacts, okay, and on my channels. Okay. This is my channel, Misbahullah Engineer, and hope you will enjoy this session. Practice on it. Especially I will advise you practice on the joint rotation, because this joint rotation is a little bit tricky. Okay. So you must make a lot of practice on this joint rotation. Okay. Because this is a little bit tricky. You have to make a lot of practice on this joint rotation. Similarly, by rotation of loads, as we will done in one of two examples, that how we will assign different types of a load which is perpendicular or inclined to a structure or an element. So I hope you will learn these videos. See you in next session, that is analysis of indeterminate beams. Watch the video and enjoy.